Okay, in this video, I'm going to teach you that how you can create the very high quality meshing for simulation of the any case. Right now, the case that I'm considering here is the Ahmed Body, and you can see the mesh which I created here. Okay, the actually this is the from the my course on the Ahmed Body that is going to be released very soon. This is actually it's available now right now online, and you can also purchase the video version, okay, recorded version, and it is only available from me, okay, not on any forum. So the geometry is here, okay. CAD model I made here, and then the like a domain, and the body of influences. Body of influences like that is going to refine the mesh in the volumetric region. Here you can see this is like over here, but actually then I realized that the important flow region is in the back side of the body where we have the slant, and we have the reverse, the separated flow and the wake region. And second is for the downstream, okay. So because it is said in the research paper on the MS body, 85% is a pressure drag, and pressure drag comes from the wake. And also we have taken care of the like skin friction drag, that is 15%, and for that we have created the y plus close to the 1. So we discuss all of these things in this video. Okay, the first thing is that I am going to like delete everything. Delete everything means everything. Okay, here it is. Okay, so this is how we opened the geometry, okay. Okay, here I'm going to discuss the different things here. Number one thing is that you can see there are two body of influences, first and second, okay. If I click here, actually the first body of influence will only refine the mesh just downstream of the slant, and I am increasing size so that it can take care of the increasing size of the vortices. And second is just the downstream of the first one. And please note this thing that if the first body influence is here, that will have the like a more preference, and the meshing of this will have the like upper hand on the meshing in the second body of influence. So don't worry about this thing. The second body influence will only be effective after the first one, okay. So right now I'm going to hide these two bodies here, and I will tell you about the size. I'm going to decide about this body influences later on, okay. And then you can see here that if I show the sizes here of the geometry, and also I want to hide these surfaces, these faces. So you can select, right click here and hide faces. Sorry for that. Okay, so okay, so the size that I decided for this front face and all other faces, excluding the rear and the slant angle, the slant side and the vertical back side. So let me like use the edge selection first here. Okay, the length is the 0.094, okay. Okay, so it's 0.0945. So let's say I want to put the 10 cells here. So size here would be the 0.009. Here what I am proposing is that I am going for like a 0.006, 0.005, okay? So I will put the mesh, and before that I want to change the physics preference to the CFD. Okay, then I will be clicking on the size, which is here, and I will choose the face size, okay? And from here I will choose the actually I cannot select from here, so either I have the option here to click on the planes here. So if I can hide the face, okay, now I guess I can select, okay. Okay, so for these four faces I will select the one size, and that is the 0.0. Instead of 0.05 I am going to select like a point, let's put the 0.05, 0.005, okay. And similarly for this one I am going to select, okay, hide these two faces, this face, and this face, okay. So for this I'm going to put the size, same size as a 0.005. So I guess that we should be making it like a 0.008. Okay, and on the two sides which are on the rear side, I'm going to put the size as a 0.003. So because we should be having fine mesh on the region where we are going to have the more flow gradients, okay. So now click on generate. Okay, now I want to just check that how the mesh looks like. Okay, these boundaries didn't define by the myself, so I'm going to delete them. Otherwise, they will make the issues. Okay, once again, create the mesh and delete these symmetry planes from here. Okay, click on the mesh and again generate. Okay, so this is like the very initial mesh. I just want to show you that what is the effect of defining these sizes on the Ahmed Body's surface mesh. Okay, this mesh seems of good quality, except the one part that is on the legs. Okay, for the legs, you can see that if I again select the edge length, so this circumference is equal to 0.09. 094, you can also include the more digits, but it does not matter actually. I want to put the 30 cells here, so size would be the 0.003. So again select the these two surfaces and put the size here 0.003. But also I want to define the local sizing, okay, for the curvature. So I want to define that the local curvature size that I'm going to define is, like I said, right now it's the 0.003. So I'm going to define the 0.305. Okay. So this is going to be my minimum size. So if the curvature allows, and so we can go to the lower side on the sizes, but if not, then this size will be there. At least there will be 30 cells will be there. Okay, so this is the one thing that we have done here. Okay, now the next size that we are going to define is on the back side. Okay, on the back side of the domain, that is the body will influences. So first I am going to display the body influences here. Okay, so choose the body and click on the mesh and then click on the sizing. So the size we are going to define is on the body. Okay, this is on the body. So this size will be defined with the help of the type as the body influence. So first body influence is here, and I'm going to put a size as a 0.01. Okay. The second sizing will be again for the same domain, because it's going to be applied on the volume region of this domain, but using the body we have defined in the design model separately, which is here. Okay. So again here it is the second body of influence. Okay, this body, and I'm going to define size as a 0.02. Okay. Okay, few more things, and before that, I'm going to define the like an inflation. Then I will discuss about the global sizes. Okay, so inflation, and before that, I want to hide these two bodies. So inflation will be applied again on the main body, but which surfaces we decide them. And the first one I will decide with the help of the name selections, and I will choose these name selections. Okay, 6 faces of the Ahmed body. Okay, here what I did is that actually I have like y plus calculator and the first cell height calculator. This is from the same y plus formula. So what I'm wanting here is that I want to have the Reynolds number, which is here, and I decided to put the y plus 2, that is required for the SST model. And for that case, I'm going to get the first cell height as a 0.40166. So let's round off the value, and I'm going to target for the 0.40 and 2. Okay, and also from the like a boundary thickness formula, I found out that for this case with this Reynolds number, the maximum thickness of the boundary layer is a 0.024. So first cell height is a 0.402. The ratio or the growth rate is a 1.2. Second cell will be the this size. Third will be this one. So up to 30, the size of the boundary layer would be the last cell height would be the 0.00396. If I sum up all these values, the total size of the boundary layer with all the layers will be equal to 0.02364. That is very close to the value here. So in the 30 layers, total height of the boundary layer will be equal to 0.02364. Okay. So this is what we are going to apply here. So I'm going to choose the first layer thickness, and then 0.40 and the 2. Number of layers are 30, and the growth rate is a 1.2. Okay. Then again, second time I am going to define the inflation on the same thing, but this time I'm define on the like this small part of the road. Okay, here, this part. So actually, I defined this separate part here. That is to take care of the boundary layer mesh on the road in the vicinity of the Ahmed body. So here I will be choosing again the first cell height, but here what is my target is that I'm going to target for my first cell height based on the y plus requirement of around less than 150 or around 100 and 120. So let's put the 125. So this gives me the first cell height as a 0.001. So 0.001. I will keep the number of layers 5 and the growth rate as a 1.2. Okay. The next inflation is going to be on the remaining part of the road. So again, the main domain is this one. This is my like the remaining part of this road, which is here. I think this is hidden. So right click here and click on display show hidden faces. Okay. Now we can select that face. Okay. This can be also selected from the name selection, and this face name is the road. Okay, here I will keep the default smooth transition method, 5 layers ratio as a 1.2, and inflation to I am going to select with the help of the name selection, and this is the road below the Ahmed body, road face below body, this one. Okay. So one inflation is on the like our main domain. Okay. Second one is on the small part of the road, and third one is on the remaining part of the road. Okay. Okay. So we have defined what we have defined so far. We have defined the mesh on different surfaces, right? We have defined the mesh on the like different parts. Okay. So now the last is on the like a global mesh elements. Okay, global mesh elements. So these elements now this actually will affect the mesh in the overall like scenario. Okay, so let's here. If we take a look here, what I'm saying is that now I will take care of the sizing between these this gap. This gap is 50 millimeter. So 50 divided by 1000 is a point 0.05 meters. If I want to put the 10 cells, the size would be the 0.005. Okay, that's what I'm saying. Okay, so I am going to select the mesh sizing and capture proximity. I will say yes. And where I want to capture between the Ahmed body, this surface and the surface here. Okay, between this surface and this surface. And please keep this in mind that I'm not going to select the edges. Why? If I select the edges, then what will happen is that the edge here of this leg, okay, and the edge over here, they will have the like a close proximity, and it will refine the mesh here, which is not required actually. That's not required here. Okay, so I want to avoid that thing. So I would just want to refine the mesh between the gaps. So I want to put the enough cells in the gaps so I can resolve the flow field very with a greater accuracy. Okay, so it should be sufficiently like a number of cells should be there. So I'm just going to define with the only between the faces. Okay, and the proximity minimum size I'm going to put is the 0.005. And the gap factor I'm going to change from 3 to the 5. 5 means that it will allow for the more cells here. Okay, and the curvature minimum size I'm going to put is the 0.001. Then the defeature size should be changed. So this should be the 1/10 of the minimum size. So I'm going to put here as the 0.301. Okay, this issue will be resolved, and I think that's all. That's all. Okay. Okay. Also, one more thing is our element size. See here, if I don't define the size of the on the any body part like these surfaces, so this will take the size from here. Okay, so see this length is equal to the how much? 3.12. Okay, so 3.12132. So let's say I want to put the 10 cells across here. Also vertically same size is here. So size should be the not more than 0.3. Okay, I'm putting size 0.3. And you see the maximum size will change to the 0.6. Okay, this is in the domain, in the volumetric size. This is on the faces, on the surfaces. Okay, so I think that now everything is already set. Now you can proceed with the mesh generation. Okay, so click on the mesh and click on generate. Okay, so now you can see that the mesh we have right now is this one. Okay, the total number of cells are around 4 million. Okay. If you think this mesh is very fine, then you can reduce the size, and also that the mesh in the gap has effect over here. Okay, and also you can see the 30 layers are made around the Ahmed body, and 5 layers on the ground, and then the second impact is like on the third inflation layer, and which was with the smooth transition. So it increases size as the size of the base triangle increases, and you can see that the transition is also very nice, and they are matching on the on the interface. Okay, here. Okay, and from the inside, if you take a look here on the Ahmed body mesh, and especially on the legs, you can see this is also very high quality, not very like a very refined, like a very fine, but it's a more than enough. Okay, sufficiently fine on the legs, and also sufficiently fine on the bottom face surface, and on the this rear and the vertical and the slant faces. And also if you take a look on the inflation layers, this is also done very nicely. If you take a look here, you can see around the this leg there should be also a mesh, but you cannot see from here. And for that you have to like put a like the section plane. Okay, there you can put from here. Okay, you can right click here and you can show all the faces. Okay, and you can also display the like 3D elements, and then you can properly see that the how prisms are growing. Okay, these are prisms on the Ahmed body, and also I want to show you on the like legs here. Okay, so I hope that you have learned a lot of things in from this exercise. This is like I covered every aspect of the ANSYS meshing, including the like face sizing, the body sizing, body influences, inflation, the global sizes, proximity, curvature based sizes. Everything I covered, I think there were much details here. Okay, and also they also impacted the mesh here as well. Okay, on the curvatures. Okay, thank you very much. And if you are interested for the complete live course, then you can contact me on the given WhatsApp number in the description. Thank you.